how disease has basically affected how humans have interacted with each other and the environment, and affected our evolution, both in biological terms and in terms of development of civilizations on a really large scale, and how we're really all here today because of these forces at work. Okay, well, first, disease. So we tend to see disease through a very negative lens, where we see it as something to be eradicated, and basically something that detracts from human life, from human quality of life, and basically something that we try to eliminate completely with modern technology and medicine. And in fact, we have seen this happen, especially with certain diseases like smallpox, which have been totally eradicated from the population because of advances in vaccinations and basically increased health, just better health, through a lot of things like sewage and political systems, and good practices like keeping our waste away from our food. And these things will all affect the transmission of disease. But from an ecological standpoint, disease really does have a point. And ecosystems would not be healthy, actually, without disease. And this has to do with populations. Basically, populations of organisms will continue to increase as long as they have resources to exploit and use, and these have a tendency to cause very large populations, and there needs to be a way to control them. And part of the way nature does this is through various mechanisms. One, predation. Like if you have wolves, they're going to eat rabbits and basically stop the rabbits from consuming everything when they breed too much. And basically, disease has in the past acted to limit populations, and to act as nature's way of maintaining balance in the ecosystem. And for much of human history and evolution, disease has really played a large role. It's basically kept human populations small, from their origins as hominids in Africa, where most people basically lived around forests and savannas, and basically disease helped to limit those populations. What changed was basically the advent of agriculture, and also commerce. Along with that, people started to build cities, cities especially along waterways, around coasts, places where they could get their ships to sail and basically do trade with the rest of the world. And while this was really good for the economy and for getting goods to certain places, like establishing the Silk Road and basically getting people to exchange goods and services and cultures with each other, cities were also bad because they also made it really easy for diseases to spread. And this brings me to a concept in ecology and population ecology called density independent and density dependent. Population control are density dependent, meaning that if a population is really, really growing quickly, and a lot of individuals will be concentrated in certain areas, like cities, but also for animals, maybe herds, schools of fish, even with a watering hole in savanna, you'll get a lot of animals congregating there to get water. That's going to concentrate the population into those areas, and so that's going to make it easy for certain things to spread, and also for predators to attack them all at once. And this is what we call a density-dependent factor. That when you basically have all these individuals in a small, concentrated area, it will be very easy for them to spread diseases to each other. And in this way, disease plays a really dynamic role in populations, that when populations are low and people are spread out, diseases tend to not spread, and the population can continue to grow. On the other hand, when population density gets particularly high, when there are a lot of individuals around and they're all congregating in these places where there are resources usually, then diseases will spread more rapidly because there will just be more people coming into contact with each other, shaking hands, or having displays of aggression and violence, or just any of the various ways that animals can interact. And basically disease will be spread among them. And so as population density increases, disease transmission also increases, and you'll basically get more deaths from disease. And this is why it is density dependent. On the other hand, you'll also have density independent factors, and these are basically factors that will limit population growth but are not dependent on the population density of that particular organism. An example of this would be largely abiotic factors, meaning just physical factors that are not biological, not bacteria or viruses. And these are things like the weather, temperature, earthquakes, tornadoes. Like, these are things that happen regularly in nature, but they don't really care about how many individuals are there or not. Basically, like, the earthquake or the tornado is going to happen whether or not there is a village there, if it's totally deserted, or if it happens to be the center of civilization. If it happens to be New York City, then there'll probably be a lot of panicking. But basically, the natural disaster is going to happen anyway, and it's going to act to limit the population, but in a way that is density independent, where basically just anyone who happens to be there and is caught up in that particular process will meet an untimely end. And then it'll just be that. Basically, bad stuff will happen, and then it will limit the population, and it will do it indiscriminately, whether or not people are together or not. So other factors that are density independent, natural disasters like volcanoes, tornadoes, floods, earthquakes, things like that. Pollution is actually density dependent, because the more people there are in a certain place, the more pollution they'll produce, and then that pollution can come back and haunt them, because it will pollute their drinking water and their air, and basically that could actually also limit the population, especially if you have certain things that cause cancer. Then you'll have people dying from cancerous agents that they basically produce themselves, and they'll be in higher concentrations because the population itself will be in a higher concentration, with the population density concentrated there. So that's just one way of looking at disease. Also, looking at vectors, things like what is spreading the disease, like mosquitoes or rats. In the case of bubonic plague, it was rats. And basically, ways we can act to limit these things that spread disease, but also act on the things that cause them to begin with, like just having unchecked population growth, using our resources blindly and not thinking about sustainability, and basically, and also living in harmony with the environment. Like, there was a way to use things, to use the soil that replenishes it, and that establishes some way for the future to continue. A lot of it has to do with moderation. Even in the case of basically fishing, fish stocks can be over-harvested, they could be overfished, and then basically the oceans will run out of fish, and they won't be able to reproduce fast enough for humans to consume them. And so a lot of it is about balance and harmony, and basically about studying nature and having a certain respect for it, and putting into practice those techniques that allow us to live in harmony with nature and to basically sustain the future. I urge you to look at things objectively, and to be curious, and to think about really just to look at the world differently, and try to see things through the eyes of a biologist, or to see the world through the eyes of someone else, that you may be surprised with what you find, and And that is really what makes biology interesting and come alive for me.